Hi everyone, it's 7:30. Lou had a last minute conflict. Yeah, he wouldn't be able to make it to the call, so it will just be Oscar and me. Uh, we It's 7:30 my time,
Yes, or
so let's get
yeah,
started. And yeah, we will. Let's. I'm hoping there'll be more people trickling in. Oscar, do you want to get started?
yeah. So thank you very much, guys, and welcome to this interim special interim on NRP. So if you go to I think you have the control. Pavan. Okay, perfect. So just our regular ITF not well. Doesn't matter that we are today just online, and as I see it on not much participant, but in any case, here this is an interim meeting of IETF, so it follows the regular processes and policies of IETF, and that all contributions here, if they are covered by patents, you must disclose them, and also follow the usual rules as in all IETF meetings. So go to the next slide. So here also even the same as in the regular meetings, we need to follow the guidelines of IETF. Okay, so here be today discuss with courtesy, with respect. All discussions keep it to the technical level and please contribute. And just I think go to the next slide because I think just we need to all the materials, all the meetings, you can find them also in data tracker. You can find all the slides that are going to be presented today. Also, for the note taking, just I suggest that the more help that we can get in getting the notes, the better. So just log there to the notes ITF org and help us in doing the notes and just they follow the typical procedure. Just use the queue control to enter in the queue and speak like a regular ITF meeting. So with this, I leave Pavan to start with the technical topic and the technical discussion that we're going to have today.
Okay, thanks, Oscar. As announced earlier, the focus of today's interim meeting would be on NRP selector. The chairs received some questions about some of the NRP selector specific documents that are progressing in other working groups. There have been also some calls to provide appropriate guidance to other working groups on this topic so that they can make informed decisions on relevant documents in their respective working groups. We have in the past discussed and provided guidance to other working groups on NRP specific aspects that influence control plane extensions. So the ask now is to do the same for NRP specific aspects that influence data plane extensions. We have some open items regarding the NRP selector and the various options for carrying it in the packet. And today's interim meeting is to facilitate the discussion on these specific open items. Uh, yeah, I'm hoping that we'll initiate the discussion here and extend that to the list. Um, in the working group adopted NSIPM pillars document, it is stated that the set of traffic streams assigned to a specific NRP may be provided the same forwarding treatment. And for this purpose, the packets associated with this aggregate may carry a marking in the packets network layer header to identify this association. And that marking is what is referred to as NRP selector. In the working group documents that we currently have, we allow for multiple options for carrying the NRP selector. There have been questions raised in the past about the need to have multiple options, so we'll revisit that as part of the discussion. We'll spend a fair bit of time in this session discussing the general options available for carrying the NRP selector in the packet and the corresponding scalability and network management implications that come with each option. We will also revisit the distinction between the NRP selector and the NRP ID and the implications that this has on appropriate identifier encoder encoding extensions. Um, After we discuss the open questions on the various options, we will then move on to the modeling uh, of NRP selector. So we will discuss how the NRP selector is currently modeled and what the plans are with respect to extending it. We also have a slot in today's session for a relevant six-man working group document that talks about carrying NRP information in the IPv6 extension header. As mentioned earlier on the list, the data plane specific extensions are not in scope for TEAS working group. The guidance and the feedback that's being sought here is primarily with respect to terminology, scale, and scope. So hopefully by the time we get to this draft on the agenda, we would have had some discussion on these aspects already and some clarity on how to proceed. So this is what we would focus on today. We deliberately did not add any other related individual documents which are targeting other working groups to today's agenda. The authors of those documents, as always, are welcome to introduce the drafts on the TEAS working group list and seek feedback. Uh, Let me go to the next slide. So these are the specifics of the agenda that we have today. We'll spend the next 30 minutes or so discussing the open questions with regards to NRP selector options. We have asked Tarek to present what is currently documented and lead the discussion on the open items. We'll then have Bo go over the NRP selector modeling aspects, and finally we'll have G introduce the six-man working group draft. We do have a sufficient buffer at the end as well, so there should be ample time for a good discussion. Any questions before we get started with the presentations? Okay, so with that, let's go to the next presentation. Tarek, you're up.
Okay. Um,
We lost Tarek. I see that he's back.
okay. Hi, sorry, I had an unstable connection. I don't know if it's the server or my connection, but can you hear me now?
We can, yeah.
Okay, great. Not sure where the problem is, but let me know in any way or manner you can if you lose me. So hello again. My name is Tariq, and this is not a document update on the two documents I have there. Um, the chairs had reached out and asked me to kind of give do a bit of homework and give an overview of the options that are known within the working group for NRP selector. So I'm going to go over known things that we've discussed in the past. I'm not going to try to make any assertion or advocate any solution.
I can hear Tarek. Is that just me or
No, I think we lost Tarek.
okay? So he's back.
Hello?
Yeah, we can hear you, Tarek.
Okay, so for some reason I'm dropping again. I hope that this is the last time. Uh, Okay, I'm going to present the options as well as some known terminology that we have defined in the working group, and then open up the platform for people later on to comment and on the questions that I'll be raising. Please go ahead to the next slide, Pawan. Thanks. Okay. Some terminology that RFC 9543 introduced. The network resource partition is the subset of buffer queuing scheduling resources and associated policies on the set of links in the underlying network that will be associated with the NRP. We have something called connectivity construct, and this is the set of uh, service demarcation points that together with a communication type like tunneling mechanism defines how the traffic flows between those SDPs. Uh, Later, we say one or more connectivity construct from one or more IETF network slices can be mapped to an NRP. And as a result, the flows that can go over these connectivity constructs need to be mapped to the NRP resources on nodes that those streams will traverse. We will be reviewing the options to identify and map those traffic streams and assign them to the resources on later slides. So let's go to the next slide, please. Continuing on with terminology, I'm extracting a couple of terms from draft TEAS NSIP MPLS, which introduced something called NRP policy, which is a policy construct that enables the instantiation of mechanisms and supports of certain service-specific either control or data plane behaviors on the topological elements associated with the NRP. So basically, in essence, we are instantiating the NRPs on the set of links and nodes using this NRP policy construct. Within the NRP policy, a term NRP ID was introduced. So this is a identifier that is globally unique within a non-NRP domain, and that can be used to distinguish in the control or management plane the specific NRP. So the NRP ID may be used, as I mentioned, as a distinguisher for different NRPs. It has to be unique. And the NRP ID is a key identifier within the NRP policy, which we use to instantiate the NRP on the nodes and links that belong to the NRP or the host the NRP. Next slide, please. Again, more terminology, and now we're going to talk about the NRP selector. So the NRP selector can be one or more fields. You can call them as markings within the packets of traffic streams that are inspected and used to map these packets onto the NRP. So the NRP selector does not have to be one field. The NRP selector does not have to be a specific field. It can be one or more of fields that the user can define in the NRP policy to distinguish the traffic streams that are part of the NRP. Once we identify the traffic streams, then we can apply the forwarding treatment that was promised for that NRP. And the forwarding treatment as well is defined in NRP policy. So one thing I want to highlight is a single NRP may have multiple NRP selectors, possibly. One can envision that a single NRP has different types of traffic, data plane traffic, MPLS or IPv6, and for each, we have different ways to identify the type of traffic. Identify the NRP traffic, depending on what fields was used as an NRP selector. So hence, we can have for a single NRP multiple NRP selectors. And nevertheless, each data plane encapsulation is working on defining different ways to encode an NRP distinguisher or identifier. So I will go over the possible options on the next slide with you. Let's proceed to the next slide, please. So options for carrying the NRP selector. This is kind of a review of the options that were proposed and known. One is to overload the existing fields in the packets. One option was to assign a unique forwarding label or forwarding address per NRP for each FEC, forwarding equivalence class. And another option is, again, in IPv6 world, either assign a different destination or source address in the packet for different traffic streams belonging to different NRPs. So that is the overloading existing fields in the packet. Another option was to assign a dedicated identifier and then embed it inside the packets that will belong to the NRP. And those dedicated fields are independent of the forwarding decision that nodes have to take when forwarding traffic. So in order to carry the dedicated identifier or distinguisher, we needed a place to put it in the packet. And there were two obvious options. One, to piggyback on an existing field and hijack part of it to put this dedicated identifier. And ideas were to, in IPv6 world and possibly in SRv6, part of the SID would embed the dedicated ID, NRP selector ID. Another option was to embed the NRP selector ID inside the flow label of IPv6. And another variant of this was in MPLS world, where proposal was to embed the dedicated NRP selector ID inside the entropy label. So part of the 20 bits for the entropy labels would be assigned dedicated to this identifier. The second option was to come up with a completely new field in the packet and carry this dedicated identifier in it. And in the MPLS world, we're working on the MPLS network actions framework, where it allows carrying a specific action and a possible metadata associated with it. And that action can reside within the stack, label stack, or post the label stack. So there are two possibilities there. Another option in the IPv6 world is to carry it in a routing extension header, the hop by hop options header. And there are proposals in doing so as well. Those were the two obvious, two known options so far. Either piggyback on existing fields or create a new field in the packet and put this dedicated identifier in it. Next slide, please. So now I'm going to double click on the various options and see if we can draw something interesting about each. The first option was to overload a forwarding identifier that could be forwarding address or forwarding label. In this option, we are assigning a unique forwarding address or label for each FEC per NRP. The per NRP forwarding state that needs first of all, that forwarding information or binding needs to be distributed to nodes to the network so that they're aware and they can program that forwarding address or label with the correct next hop information. And so a distribution mechanism is needed. The second thing is the forwarding plane needs to store additional or more state. It's per NRP forwarding state that will be needed. Inspecting, more, if we have a node with M NRPs that can reach N destination nodes, then a node will have to store up to M times N forwarding identifiers in its control plane as well as data plane. So this is just loose hop kind of routing, but you will also possibly have some strict kind of addresses, on your adjacencies, and it can blow up very quickly the amount of forwarding state that you need to store in the data plane and the associated forwarding information in the control plane. Next slide, please. Now we talk about an existing field in the packet that can be doubled as an identifier. One option was a service identifier that the traffic streams could carry. This could be a VPN label, for example. A service identifier, for example, a VPN label can be inspected by the nodes and map the traffics to different NRPs. Again, there is a need to distribute this VPN labels or service identifiers to the nodes in advance so that they can inspect the packets as they come and classify them or map them to the respective NRPs. Options to do this distribution, carry it into the NRP policy, which was an option considered when the NRP policy was modeled. We have a data model that I think Bo will be presenting, and she'll be talking about the options. The other option was signaling this information. Again, I will be talking more about signaling and carrying this information in routing protocols on the next slide. Next slide, please. All right, so I did mention now multiple times that we need to distribute the per NRP information somehow to the nodes that are part of the NRP. And people have already started to think about how we do this distribution. Maybe an obvious way to do that was, start extending the signaling or routing protocols to carry this information. This option have been discussed within the working group. I know I was in multiple discussions and multiple people, brainstormed this option, and kind of a rough consensus was to go against this approach, and a recommendation was added into the NRP scalability document. I am extracting a text from revision 3 of the document, which states that the routing protocols, be it IGP or BGP, do not need to be involved in any of these points, not mentioned, but this is an extracted text. And it is important to isolate them from these aspects in order that there is no impact on scaling or stability of the IGP or BGP. Other ways of distribution that was thought of, again, was via the management plane, and modeling the data that needs to be distributed in Yang, for example, and then distributing this via an interface, suitable interface. Okay. Again, I am opening the questions, and I'm hoping that this can trigger some debate within the interim. So next slide. We have an option to dedicate an NRP selector identifier and not overload another field in the packet for the purpose of uh, selection of the NRP traffic. So this dedicated NRP selector identifier can be used as the NRP selector, as I was saying. And the NRP policy, which is one way to distribute this information to nodes, can carry this NRP selector identifier and distribute it. With this approach, you will note that we're not affecting the forwarding state on the nodes. We're not extending routing protocols, and we're not adding, control plane state as well. One drawback is we need the hardware to understand the new field that we are going to embed this dedicated identifier in, and so that it can parse it and extract the field and do the proper mapping. So if certain hardwares don't support it, unfortunately, the other options would be the alternative. Next slide, please. I'm going to talk about NRP selector versus NRP ID. There is some, it turns out there's some confusion there. I did mention the NRP ID uniquely identifies one NRP, be it in the management plane or, a user defines an NRP, he has to give it a specific unique ID. And I did mention that one NRP can have multiple selectors, NRP selectors. So in NRP, nevertheless, also I mentioned that an NRP selector may or may not be a dedicated identifier. So it can be this NRP selector ID that was dedicated for identifying traffic, or can be a forwarding label that's bound to the NRP that we can identify traffic with. The NRP ID I mentioned is a key identifier currently defined as a 32-bit opaque identifier. It does not need to be the ID that we carry in packets. It doesn't have to be 32 bits. And I will come to the scalability aspects later on. I mentioned that the NRP ID need not be the same as the dedicated NRP selector ID, but in some scenarios, the user might want to embed, the same NRP ID that they defined in the management plane inside the packets. They want to embed the same exact same ID, and that will only be possible if the number of bits that we defined in the packet itself, the encoding can fit, the management plane NRP ID. So if the user had assigned IDs that don't go beyond what's defined in the packet. So that could be possible, but it's not always the case. Next slide, please. So here I'm, raising some questions, and they're still open. We have multiple options for the NRP selector. I went over multiple options, and do we want to leave all the options on the table? Do we want to keep one option? So that's still, we can still keep this debate going on and hear opinions. On the scale aspect, one question that came about in the past and still open is how many NRPs can we have in a specific domain, and maybe that will dictate how many or how big is this NRP selector ID, and maybe in the management plane it dictates how big is the NRP ID as well. And it can dictate how the encoding will look like in the packet. Maybe it can fit in that field or it doesn't fit in that field. So depending on the expected number of NRPs in the domain. I should mention that The MPLS working group reached out to 3GPP via liaison, asking about at least the number of slices they expect. Unfortunately, we did not hear back. I know Loa did work on text in the past. I don't know if he's on the call. He's not. Oh. Yeah, so we had this liaison. We still have not got any response. Now, last bullet I want to talk about, given that we will be defining, there will be hijacking a field in the packet, or maybe defining a new field to carry the NRP selector ID. Should there be flexibility in the number of bits allowed? Meaning, should there be variants, a narrow variant and a wide variant? Some proposals have already, in MPLS world, have proposed different variants, but maybe that's another question we can think of. Yeah, and should there be multiple encoding options per data plane? That's a bigger question mark. There is, do we want to support multiple solutions? Next slide, please. I believe that.
That's the end of the deck. I think we can open up the floor if anybody wants to chime in with answers or thoughts on any of these questions. Don't be shy. Ketan.
Hi, thanks, Tarek, for putting those slides together. It's very helpful. I had a few things, and probably it can be a discussion. The first question that I had is, in your first slide, Tarek, you mentioned two documents that are related to NRP, the scalability and the realization in IPMPLS. From reading, my impression is that scalability document is for discussion of the scalability aspects, while the other one is actually how they could be realized. Is my understanding correct?
So I can probably explain. So we have multiple realization documents in the working group. The NSIP MPLS document talks about realizing network slicing using the notion of network resource partitions. There are other documents that talk about realizing slicing without the need for any partitioning. There's also a document that talks about doing everything in the management plane. But yeah, you're right. So the NSIP MPLS document, from an NRP's point of view, that's the realization document. And the other document talks about the various scalability considerations that would come into play if you want to use NRPs.
Okay. So, I mean, if somebody were to go and add some extension or start work in some other protocol working group, uh, the actual requirements or the outline of the framework for that should come from the the realization document, right? Is that again correct? Because
It's
just
still
wanted, it's
Yeah,
still fluid.
it's still an evolving document.
Okay.
That's why we are having these discussions. Today's session is primarily
Okay. So,
scoped for the date for NRP aspects that influence the data plane extensions. I understand that there are there are some open questions with regards to control plane extensions, but
uh,
that's
yeah, so the reason why I brought this is there are some there may be some contradictions, and those two documents are not aligned. So it's even for the data plane discussion, as we'll see, they are not necessarily aligned. So I think it would help with clarity on that one. I mean,
if you can call out
for,
the misalignments on the
sure,
list,
sure.
we can definitely discuss
Okay.
those. But yeah, the point of the session today is to see if we can converge on the various terms that are being used and the various options that are on the table.
Okay, so on the terminologies, on slide number 3, if we could go to the slide number 3, Yeah. So there is this is where NRP ID has been introduced. I understand. Now, from the definition, it looks like actually that's a NRP policy ID,
Hmm.
right? So
Hmm.
I see that, and there was something that Tarek mentioned. Tarek, you mentioned a little further on the slides that the NRP policy ID could be different from something like a NRP
Yeah,
data plane ID.
right.
Uh,
Yeah, it's
so I'm just wondering if using the two different terms can disambiguate the policy identifier, which is the 32-bit number, as you're saying here,
mm-hmm.
versus a data path identifier, which is, like you said, maybe a narrow or wide, but maybe a different number than this.
Exactly. Yeah, that was my intention, is to highlight that, indeed, we can have a dedicated ID and we can call it NRP selector ID, or, I come up with another term, um, which is different from the ID we gave for the NRP in the management plane. But I left the last bullet there on purpose, that some people might want to still go ahead and, kind of crunch the management ID inside the packet. Um, keeping in mind that it might not always fit inside the field that we will define. So if they want to do that,
Yeah,
that's fine. But in terms of, what we call it, to remove confusion, I think we should distinguish
just a
them.
suggestion to use different terms and something which is in the data path to use maybe a term which has data path in it, or something appropriate like that. Uh, and in data path, we have had, for example, with QoS, we have had this precedence where across like domain or region or AS boundaries, some of these things need to be remarked or updated. This kind of sometimes help in scaling, but also sometimes help in aggregating. It may be that uh, the NRPs have different meaning, or let's say n number of NRPs in one domain could map to a single one in the other domain, as an example. So this notion of being able to map might help in scalability and deployment, because it's possible that not all platforms or routing hardware have the same capabilities, and mapping helps. That's another reason for disambiguating the management plane notion of NRP policy with what's in the data path. I don't know if
Yeah, it makes
others have.
sense to me, at least. I understand.
Uh, okay, if there are no more, then I'll go further. Related to your question on the 11th slide, both are a dedicated field. I think my sense right now is that longer term it may be simpler or easier to do a dedicated field option or a header in the for different data paths. But we might need, it would be good to have some flexibility in the interim or the short to medium term until all the hardwares are upgraded and can have this capability, to use the notion of NRP selector that is there to pick or use any of the other existing fields. uh, I think this would help uh, at least get some of this rolling out without waiting for the hardware upgrades.
Okay. Okay. Thanks, Ketan. That's
Thank
useful.
you.
Anybody else wants to chime in on the first question? Uh, G, go ahead.
Can you hear me?
Yeah, we can. Yeah, good.
Yeah. Firstly, I have some small questions about the overload approach mentioned in the slides. The first is about the source address. I think uh, for the overloading, I think maybe we want to reuse existing forwarding mechanisms, such as we can do the NRP matching based on the destination address, based on the forwarding labels, or even other labels which can be parsed in by the node. But the source address is a little bit different. Usually in the IP forwarding, we don't check the source address field. So I'm not sure it's can be one option in overloading or the overloading existing field for an RP selector.
Jimmy, just to try to answer the idea of um, using different the sender using different source address. Um, basically, if they want to send traffic for NRP red, they will use a loopback red on the same sender. Otherwise, if they want to send on green, they will use a loopback green. Obviously, that means that the node will have multiple IP addresses assigned to it, uh, and they would need to be reachable. Maybe the other nodes need to send back some information on that red loopback or green loopback. So it has some connotation with it. I mean, some overhead, but still people might think of it. And even there are proposal of embedding the dedicated ID inside the source address. So I've seen one in the SR world where part of the SRv6 source address is just put aside for this dedicated ID. So not the full source address, but part of it.
Yeah, that one is a different approach. For this one, I guess you mean each node can allocate or assign different loopback address for different NRP. Then that address can be used in packet forwarding, right?
Yeah, I mean, I'm not saying it is the solution we want to pick. I'm just saying that it is one
Yeah.
option.
So this slide, my understanding is that this was added to just highlight all the solutions that folks have been proposing in various working groups. We in TEAS don't need to, uh, come to any conclusions on what specific data plane fields need to be used. I think the question that
Okay.
we need to answer is whether in the NSIP MPLS document or or say in the uh, NRP scalability document, whether we uh, have text talking about both the overloading existing field option and the assigning a dedicated NRP selector field option. I think we heard one voice. I think Ketan uh, said at least in the interim we would need the both the fields to be both the options to be allowed, uh, and hope that uh, eventually the deployments will move to using a dedicated selector field. Um,
Yeah, I think on that one, I would agree with Ketan's view on the short-term and long-term uh, use case. For the short term, as the number of NRP needed may be not that many, and the overloading existing field approach can meet some requirements and without upgrading the hardware. And this can and it will not bother by the scalability issue because of this deployment case is maybe just can be under the control of this scalability. But for the long term, definitely we expect more NRPs will be needed, and as more use cases and more services will need this feature, so that dedicated NRP will be more scalable and can reduce some overhead in both the data plane and control plane. So that is the long-term option we see.
Okay. Um,
Yeah, maybe I want to mention one more thing is about the management plane versus control plane. I think this was
before, so G, before you ask that question,
okay.
Ketan, did you have a follow up to what G mentioned, or
Yeah,
uh,
yes, yes. Just a very quick follow up on that. I think one way to look at it is NRP selector is actually more like a NRP classifier, which works on the data packet fields or other things, right? And it could use any existing field, or it could use a dedicated field. That's just the, let's say, the configuration inside the classifier. If we model it perhaps in that manner, then the same thing works for a short term, and eventually it can be migrated or upgraded to the uh, uh, dedicated field. So selectors, I'm not sure, like selector classifier seem like uh, maybe a more appropriate to me, but yeah,
okay,
that was all.
G, go ahead.
Yeah. Let me continue with my point. What I want to mention is for the scalability. I think the slides mentioned that the management plane can be more scalable than the control plane in the NRP information distribution. But I'm not quite sure about that because the overhead or the amount of information to be distributed will be the same. But maybe the management plane, the control plane, they have their pros and cons in different aspects or different scenarios. Maybe we may not give that conclusion that easy in that slide. That is my opinion.
Okay, Ketan.
Hi. So there has been a general pushback in other working groups, LSR, even BGP, to into for pushing management information inside control plane protocols, because it affects the scalability. It's increasing the LSDB size and all sorts of things. So from my understanding, NRP is completely, I mean, not related to the topology or the routing, uh, path selection or anything of that sort, right? If that's the case, then it is. I think there was some agreement from what Tariq mentioned, that we should keep this out of the control plane protocols like BGP and IGP. I think there was an agreement, right, Tariq? There was some text, but again, I'm confused because the text is in the scalability document and not in the realization document. So
Yeah, so I would like to flash that text, please, Pavan. If you go back to that slide again, I can't recall which slide I put. Yeah, this one. Yeah. So it was put in the scalability document after discussions within the working group, and agreeing that we don't need to overload BGP and IGP with NRP information, because it will in fact impact the scale and the stability of those protocols. And yeah, I mean, the members agreed to look for other means to distribute the information. Um, I don't want to, I did send an email last night. I was checking revision for, but because you mentioned this now, I'm obliged kind of, I noticed that, even the text in revision 4 of this document is now changed. So I would like some understanding why did we make that change. So it's now kind of hinting that routing protocols can be changed to distribute the information.
So let
Um,
let me suggest something. I mean, we can discuss the control
yeah, I
plane
think it's,
aspects, the management
yeah, it's a
aspects on the
separate.
list. So today I would like to keep the focus on the NRP selector specific questions that we have. But yeah, your point is taken about control plane extensions. In general, we have been letting the respective working groups reach out to us whenever there are questions with regards to any new control plane extension getting discussed. And I think there were at least a couple of documents for which we provided feedback. We will, there is like Tarek did start a thread last night, I believe. So if you have any follow up regarding that, yeah, you please use that thread. I do want to. I mean, we have like 40 minutes left on this call, in the session. So I do want to hear some thoughts on the $1 million question: how many NRPs are enough, or how many NRPs should be the uh, so that question keeps coming up. I think it's been coming up since the day the term was coined. I don't think anybody has a good answer, but it would be useful to think about what is a reasonable range, and what is the minimum, what is the minimum, what is the maximum, that kind of thing. Anybody has anything to chime in on that? Okay. I see Kate. I see Ketan.
So I think it's maybe because NRPs are associated with queuing and buffering and classification, and maybe not classification, but if you consider selector as classifier, then those kind of resources, they are limited on a given router, and the capabilities vary based on platforms where they are deployed, like a pure core router or on the edge and things like that. Now that's on the router, but across the domain it depends on what is it are the flows that are going, are they point to point, and are we carving out something there in that point to point, or are they like multi-point to multi-point, like a VPN service? And how can we carve that out? How can we ensure that as topology and things change, that the other routers where the path changes, right, needs to have that things provisioned. So from an operational aspect as well, I think it's pretty challenging to have a large set of NRPs. At least in my discussion with operators, the numbers I've heard are very small. But I think it would be helpful to directly hear from operators, and more, not just the answer to the question, but how do they actually plan to use it or realize it.
Okay. Yeah, we will take that. I think G is joining the queue.
Yes, as Curtin mentioned, that the number of the NRP depends on the capability of the device, like the queuing resources, and also depends on the use case and the requirements. From the device perspective, I think currently the modern device routers usually have a large amount of queues, which can be used to support the NRP with a relatively large number of NRP per node. And also we can take this, think about the network-wide, maybe for each NRP it can just occupy a set of the nodes in the network, which means the number of the NRP in the network will be also depends on the number of nodes and how the NRPs are planned in by the operator. So this number will be not just the number of the per node capability, it will be much larger than that.
Okay, Ketan.
Just a follow up on that. So generally platforms on the edge have more edge capabilities and therefore much more queues. Generally again, I'm saying generally, it doesn't have to necessarily be the same, but in the core, which is where most of the flows will converge, have limited resources. So I think when we, it doesn't, I'm not sure if it helps having large number of queues on the edge, but the cores can only support a small number, and then we still want to do NRP edge to edge. I mean, this is where things like aggregation will probably come into play, and I mean, again, more discussion, more of feedback from the operators will help, but it's not. Yeah.
Understand the reason why this question is there in this session is because this has a bearing on the number of bits that we need to set aside for a dedicated NRP selector, right? I mean, what is the minimum number of bits? Is 8 bits enough? Uh, should there be, like, I think Tarek also mentioned that there have been some drafts out there that are proposing like multiple options for a given data plane. I think that's the last question there. Should there be multiple encoding options per data plane? And having some uh, idea on how many bits are too many, or what are the minimum number of bits, I think would be useful guidance as we as these working groups go ahead with determining how many bits to set aside for this. Okay. Anybody else has any thoughts on any of these questions before we move on to the other topics, with the other presentations?
Hi, Pavan. So I just speaking from operator's perspective, the only, let's say, I wouldn't say similar, but at least the only precedents that we have also where we have really dedicated resources is when we have done VPNs with RSVP-TE. So in that case, yes, it's really dedicating part of the part of the flow. So in that case, the order of magnitude that we have had for those, okay, and even that we have today in production, for example, in our international networks, can be in the order up to even could be up to 100 in the total network. Okay, so in that order of magnitude, when we are speaking about reserving resources, okay, I guess this is the question that you have, because here we are talking about a strict reservation and not just loose reservation, where we could have potentially up to thousands or even big numbers. I guess here we are talking about so that's the only, let's say, reference that I can give. But for future, for slicing, that will that will I was speaking with Luis. This would be very business dependent. Okay, so how are we able to, or how applications really require this strict, really strict reservation, okay, versus just being so consider also that at the beginning we will have, for example, dedicated slice for the radio network. There, of course, I think that that's a clear case, but other other slices that go, for example, to the as the example that we said before, evolution of the commercial VPNs with that, well, I expect the number to be uh, in the order, at most in the order of hundreds at most. And just taking the example with VPNs with RSVPT, okay, that is the closest thing I know.
Okay. Well, yeah, we'll have the discussion extended to the list, and let's see if we can get more inputs on this, and then try to draw some conclusions from it. So with that, we have about half an hour left. Let's go to the next presentation. Yeah, Bo, if you can keep this within like 15 minutes, they'll then have G cover his in the remaining 50 minutes.
Yeah, thank you. I can go quick. Hello, everyone. This is my name is Bo, and I will give the status of this NLP young models. Next slide, please. So this draft is was adopted in last IETF meeting, and as Tariq just presented, this NLP definition is from RFC 85, 9543. So the model is based on this core definition from network slice framework. And it also, as Tariq presented, it's modeling, expand the definition based on the other two documents, network slice realized in IPMPS network, and also network NLP scalability drafts. Both these two drafts defines more concrete NLP components. So the model also expand the definition based on these two drafts. So they cover the most the components Tariq just presented, such as NLP policy and NLP selectors. And since these two drafts indicate there are multiple NLP data plane options, so the model also define in a flexible way to try to accommodate all these options. Next slide, please. And here is because this interim meeting is just for focus on NLP selector. So here, this slides is about how the NLP selector is within this NLP instantiation model. As Tariq presented, NLP policy is intended to be used to instantiate an NLP instance. So here you, on the right-hand side, you can see that each NLP policy has a name and also has an NLP ID associated with it. Now it's a unit 32 bits, and this NLP policy has major 4 components inside it. Within it, it has a topology that with nodes and link in it, and also the resource reservation dedicated to this NLP, and NLP selector is used to identify these resources, and then a per hop behavioral profile will be applied to this selector. So this is, you can see that the NLP selector is part of this policy model defined in this way. Next slide, please.
There's a question, Bo.
Yeah, okay.
Greg.
Go ahead, Greg.
Yes, hi, thank you. Actually, that very helpful, this slide, because in the course of Tarek's presentation, I thought that NRPID is the name or is identical to the name of the NRP. So, but here you presented as a separate entity, so that the NRP has a name NID? Could it be a single element to do?
Yeah, I think that's a confusion comes from that. Tariq, can you answer this?
I know Ketan is ahead, but if you allow me, Ketan, from experience, I know, for example, in the PSAP world, they have a symbolic name for the instantiated LSP from the controller, and they have this unique ID for the LSP. Similarly, here we have a symbolic name. Um, it does not have to be. It can be unique and recommended to be, but the NRP ID is the key that is used, to identify or distinguish an NRP policy. And this is usually, you know, uh, 32-bit is better than an open source.
But I'm not sure that here in this Yang model, it's guarantees that NRP is unique, because if we do list with indexed by NRP ID, then yes, I agree that NRP ID is unique, and the list of NRP policies is indexed by NRP IDs. So maybe that's the approach.
I see. I understand, Greg. Yeah, I believe we have it. We have in Yang unique keyword.
That is
So
correct.
yeah, it's already unique. It is specified as unique. But I understand. Maybe. Okay. Yeah, it is unique.
Yeah, we can take it offline.
Yeah.
Yeah, one I think I think one clarification is typically if you look at the various constructs that have been modeled in across the routing areas, most of them have a symbolic name as well as like a numerical identifier, and both are unique for a given construct. And I think this is just following that model, but yeah, I think this point can be discussed on the list.
Okay, thank you.
Yeah.
Ketan, go ahead.
So
Yeah.
okay.
So one suggestion would be to perhaps consider renaming NRP ID to NRP policy ID, because the key is name, policy name, and then the ID is the policy ID.
So
And yeah, sorry. Go on.
agree. So this was discussed. I think I think it went, but the reason why it's NRP ID is because the policy is trying to instantiate the NRP, and
Right.
this is identifying there's a one-to-one correspondence between the policy and the NRP that's instantiating. But again, yeah, it's something that can be discussed.
Right. So okay, and that was my second part, is that there is perhaps a need to disassociate. So if the NRP ID is just more of not something in the packet, then I would agree. But if it is something in the packet, then perhaps we need to support for like an aggregate use case, right? When in some part of the network, I could carry multiple NRPs could carry the same, let's say, aggregate ID in the packet. So there doesn't have to be a 1:1 mapping between the NRP policy ID and what's carried in the data packet.
Yeah, because that will be going to next slides. You mean that one NRP policy can have multiple selector? Is that you? I mean that's made from the issue from Ketan, right? Yeah. So this is for NRP selector modeling. So here you can see that as Tariq presented, there will be multiple option here. And you can see that right now our model only has defined one dedicated one that is IPv6 hop by hop extension. Other than this type or the other one, they belongs to the mechanism Tariq mentioned, is overload the existing mechanism, including ACL, like the IPv4 one. This has been discussed in network slice IPMPS. Destination prefix can be used to distinguish that NRP. So this is a selector. And here we also have a list of it can be specified in case of some scenario that that multiple one used to classify that to NRP. And for IPv6, you can see we have both seed-based and also destination-based, similar with IPv4. And these also overload existing mechanism. And this definition also mentioned in network slice IPMPS and also NRP scalability. And the last one, I skip MPLS, and ACL is defined to accommodate in case of multiple like header, multiple field in the header needs to be used, such as source address and destination address can be used to classify to an NRP. And MPS here, it's right now it's just a placeholder because MPS working group is still discussing the mechanism to whether use dedicated one or the derived ones. So this is an NRP selector modeling, currently defining model, but I think this definition doesn't cover all the mechanism presented by Tariq, because I think this definition can be extensible in case of different use cases. So that's, is there some question on this slide? So in case, next step, because today we are focusing on the NRP selector, but next step we'll explain this more. And in case there are more comments on NRP selector, we'll improve the models. And also we received the comments from that we don't explain enough that how network slice service model can be used together with this NRP model. And also we're working on the issues collected in working group adoption. So that's the end of my presentation. Thank you.
Thanks, Bo. So if there are any questions on the model, yeah, we can discuss that on the list. I think we did get a few questions. I think the discussion on those can continue on the list. Let's go to the last presentation. G?
Yeah. So, hello everyone, this is Jiedong, and I'm going to give a quick presentation about the NRP idea on information encapsulation in the IPv6 extension header. Okay, next slide, please. So I will skip this background introduction because we already know what is NRP, and this is just to carry the NRP information in the IPv6 hop by hop extension header, because every node along the forwarding path need to pass this information to get the NRP information to get the proper treatment for the packet. And also not in the 6-man working group, there was some comments about whether we can extend this or make this option more general and for so that we can allow future extensions for other use cases which are similar to the NRP case for network slicing. So this is the updated encoding of this NRP option. As you can see, there are some fields introduced in the text. Firstly, we have this NRP ID. It's a network-wide unique identifier of an NRP. And we have
Can you guys hear G?
No, I can't.
No.
No.
Oh, we lost G.
I also got disconnected. I don't know. Maybe he also.
He's here. He's back. G, can you hear us? Okay, because he's rejoining. He's back.
you hear me now?
Yes. Yeah.
Sorry.
Yeah. You have Ketan in the queue. Do you want to take a question?
I'm not sure whether
I would let
finish
G
this
finish this
slide or
slide.
not.
Yeah.
Okay, good.
Yeah, I think I just introduced some fields of this encoding, right? Just I want to mention that the context type was introduced to address the comments about the generalization, so that we can introduce other semantics and the length of the NRP ID by introducing other context type values. And we also see that the data plane processing overhead has been taken into consideration. The length of the NRP ID will be fixed for each specific context type. And the format just covers the necessary information in an efficient manner. Okay, let's go to the next slide. Okay, this is the update in the recent version. This is mostly about the terminology. We align the terminology with the IETF network sliced framework and also the NRP related drafts in TEAS, so that we have renamed the option and the ID as NRP option and NRP ID. And so also we add more text about the usage of the S flag to show that it is a useful mechanism for fine granular control the forwarding behavior. Okay, next slide,
Could
please.
I ask a question on the S flag here? G?
Okay.
So the S flag, I think, is something to discuss here in this meeting, because what it indicates, and G, correct me, is that even if the packet arrives with a NRP that is not provisioned on the router, what is to be done with it? Is that correct?
Right.
Right. And the actions would, I mean, now if NRP is about a resource guarantee end to end, then I think it's probably a question or something to cover in a realization document of what happens or what is the behavior that we need or expect for such packets, right? Because they would probably break the SLA until somebody from the management plane comes and provisions those resources. So I'm not really convinced that we need this S flag. It probably is more likely local configuration. But yeah, I mean, I just wanted to bring that point up here.
Yeah. In my understanding, if you think for some scenarios you don't want to drop the packet with when the NRP ID is not matched with a local provisioned resource, then you need to consider how you can control this and how at what granularity.
So
Did I
it could
lost
be
again?
yeah. So it could be a set of NRPs are let's say loose and the other ones are strict. So if it comes for the strict, I don't know, probably drop the traffic. If it's loose, then just give
Yeah,
best effort treatment. But I think my point was that this probably needs some discussion in one of the NRP documents, I believe, for the data plane.
yeah, that is maybe we can add some text or
My
description about the different behaviors. But this just show the one usage of the flags, which we may need to reserve in the data plane so that we can introduce other similar behaviors in the future.
Right. And last bit, and this would need to be probably consistent for other data planes as well, like MPLS. So some of these behavioral
Yeah,
aspects would be good to capture as requirements in our working group draft. Is what I feel.
yeah,
Sure. My recollection is that there is some text already that talks about what to do when the packet arrives and you're not able to map it to a particular NRP. As G mentioned, I think the options are either drop the packet or map it to give it some default treatment. But I agree that yeah, it should be consistent across different data planes.
right. Okay, let's move forward. Next slide, please. Yeah, this is on this page we just want to check the opinion about whether what kind of information are considered needed in the dedicated NRPID encoding approach. The identifier we think is the basic information which is a must, and the flags as flag is just an example, and we can we have the we may need to introduce other flags for the control of the forwarding and the conditions and the behavior. The reserve field is for some future extensibility for this data plane for the option. And the context type is, as I mentioned, for the generalization for other use cases which are similar but maybe have different semantics or even the size of the ID. Okay. Any question on this page?
Yeah, no questions. Go ahead. G, you still there? Can anybody else hear G?
No, no.
Okay.
Mm, 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 mm.
G is back.
Can you hear me now?
Yeah, we can. Yeah,
Sorry, I dropped again.
no problem.
So let's move to next. This is another discussion point on the terminology. As Tariq mentioned, we have the NRP selector and the NRP ID. The NRP selector, to my understanding, is a general term to refer to all the possible data plane fields which could be used to classify or determine the NRP to which a packet belongs, and can cover both the derived or overloading existing field approach, like the address, MPS labels, or SRCs, and it can also cover the dedicated ID approach. Here we have maybe something we want further to be further clarified is whether the NRP selector for some of this overloading approach, is it does it apply on the ingress node only, or it can also be applied to every intermediate node, like using the ACL based approach? Is that just happen on the ingress, or we also need to have this ACL rules being provisioned every hop? So this is something maybe we can discuss. And the second is for the NRP ID, it is the identifier of an NRP, which can be used in the management plane, the control plane, and the data plane. And our opinion is the length of the NRP ID in the different planes could be the same or the different. And the length of the NRP ID in the different data plane encapsulations could be the same or different. So here the question is whether which term we should use for this IPv6 hop-by-hop option and the identifier, whether we call it an NRP selector or we keep using the NRP ID for this case, for the data plane. Yeah.
Hey,
Correct, go ahead.
hi, Jimmy. I heard a comment from Ketan saying that it's desirable to generalize that hop-by-hop option that you're defining. So why tag it with NRP? Maybe just keep it as a distinguisher, and then and we can use it as an NRP selector, but it's just a distinguisher sitting in the hop-by-hop option. Is that something? And maybe other applications can use that in the future. I'm not sure if that's what he meant by generalizing.
Can I follow up?
Yeah,
So
good.
yeah, so G and I have been discussing this offline, and one of the feedback, and this is specific to IPv6, is that there is a limited, I believe, some 10 odd options left for hop by hop come destination options in IPv6, and therefore there was a desire to conserve, and that not every such use case ends up using one hop by hop option. And I think I mean, again, this is not for TEAS, it's probably in 6-man, but we'll have to work something out there. But the input from TEAS to answer Tarek's question, and like what G was saying, is we still need the input on the size. So I think that would help.
Okay, thank you. I think this is some useful feedback.
One more from me, G.
Yeah.
So
We are down to the last 2 minutes,
Okay.
so yeah, go ahead.
okay, so it's a comment on one of the bullets you have on the slide. You're saying that different data encapsulations could have different size. Is that what I'm reading? Why do you think
Yeah.
it's? Why do you
Yeah.
think different data plane encapsulations might have different size for the ID or whatever we want to call it? Is it because the number of NRPs might be different? Is that why? Depending
Yeah,
on
that is maybe one possible
why would you think
case.
if I have,
Like depend on the at which stage you want to use this technology and the scale of the network. And also, there are maybe some limitation in the data plane for some protocols that larger ID may not be that easy. So it's but we should not limit the size for other data plane based just because of the limitation of one data plane. So we think that should be flexible for different data plane, and just maybe as maybe Pavan mentioned, we can give the minimum limit which should be supported by all data plane. But for the upper bound, just each protocol can have its own choice. Yeah, that
Yeah.
is my understanding.
Yep.
Okay. Yeah, I think we are at the end of the scheduled time. G, did you have more stuff to cover, or is that pretty much
I
the set
think
of questions?
this is almost what I want to present. Thank you.
Okay. So yeah, it's been useful discussion. We clearly need to extend the discussion to the list and try to get more inputs on this. I think we did get some useful feedback, at least on a few things on the way forward. So Oscar and I will sync up, maybe start some threads on the list for some of these questions, and then eventually we'll try to draw some conclusions from those. Thanks everyone for participating. We also have there's a NMOP session next week, an interim that's it's currently tagged as an NMOP session, but for all practical purposes, it's also it's kind of a joint TEAS effort as well. There'll be a 1 hour dedicated time for TEAS topics, primarily talking about um, the applicability of the T topology model for digital mapping for the digital map. So I'll send some. The chairs will send some details on that to the list. But yeah, just wanted to point out that there is an interim that you might want to keep an eye out for next week. Thanks everyone.
Thank you. Bye.
Yeah, bye.
Bye bye.